Bismillahirrahmanirrahim. Let us continue with our exploration of the vertical motion equation. Now look what we have accomplished so far. We took the vertical motion equation in its generic form and we wrote it out for our particular scenario over here with the basketball, and this was a specific scenario with the velocity, initial velocity being 24 feet per second and the initial height was 6. And we used that to find the height of the object at any given time. And then we also used it, very importantly, to find out how long it will take for the basketball to hit the ground. That is, the height of the object was 0, and we figured out how much time it would take for it to do that. And we did that with the aid of the quadratic formula here. There's one question that we have yet to answer for ourselves, and that is, what's the maximum height? What is the maximum height of this basketball, like right over here? How high is that? Now, to appreciate that, first we have to understand that this is a quadratic function. And in fact, it is written in the standard form such as this: ax squared plus bx plus c. And in particular, this is a quadratic function that is like upside down, kind of like this. So it's a quadratic function where a is negative, right? It's an n, it's not a u, okay? So it's a quadratic function where a is negative. And when a quadratic function is like this, the maximum height is reached at the vertex. So this is the vertex, okay? That's the vertex of the function. And the vertex, the ordered pair corresponding to the vertex, is the vx and the vy. In this case, this ordered pair that corresponds to the vertex, that is going to be the vx and vy, and that corresponds to the time, right here, the time, which is the x coordinate, and the height, the maximum height. Okay, the maximum height of the basketball, doesn't it? Right? So the vertex of this basketball is the maximum height of the basketball, and the time that corresponds to the vertex is the vx, and the height that corresponds to the vertex is the maximum height, therefore. And then, if you realize, this is a quadratic function in the standard form, and the way you find the vx, the x component of the vertex right here, is by the formula opposite of b over 2a. So in fact, we can find the time, this time over here, which is going to equal to the vx, from this function quite easily. So we go like this. So the vx is going to equal to opposite of b over 2a, and this negative 24 over 2 times negative 16, like this, because b is 24 and a is negative 16. Negative 24 over negative 32. Okay, so that's the time it takes for it to reach the vertex. And that is 0.75. In other words, it will take about 0.75 seconds for it to reach the vertex. Okay, now all that we have to do is find out the height at 0.75 seconds, right? Then we just have to substitute that in our equation. Negative 16 of 0.75 squared plus 24 times 0.75 plus 6, and then we will have the height. And if you do the math here, this comes out to be, the height comes out to be, the height at 0.75 seconds is 15. The maximum height of this basketball is 15 feet. And there we have it. Now look, I hope you appreciate the beauty of this particular situation. Now the vertical motion equation describes the path of every projectile object, whether it be a basketball, a ping pong, or a rock, or a pebble flying across the pond. Okay? And you can use it to describe the height of the object at any given time. You can use it to find the time it takes for the object to land on the ground. You can also use it to calculate the maximum height of the projectile. I hope you appreciate this. Inshallah, when you master this, you'll see it's nearly not as daunting as it appears. And when you do gain the mastery of it, you will also, I hope, begin to see the beauty of it if you haven't already done so. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.